more formal definition, but that in essence is it.
All right, I got you.
So how would we go from that acceleration, if we had the acceleration versus time graph, how would we go from that to the velocity versus time graph if it's not a constant?
All right. Two approaches. So if acceleration time, you want that to be linear?
Yeah.
All right. I know that my acceleration starts out small, which means my velocity is not changing much to start with. As my acceleration gets larger and larger magnitude, my velocity is going to change more dramatically. So my velocity time graph it's going to start out, I know if acceleration is 0, my velocity time graph is horizontal. So it's not quite starting at 0, so it starts out though with a small slope, and the slope gets bigger and bigger. Now I can double check myself by going, all right, if this were my velocity time graph, would that be the acceleration graph I got? Well, it starts out at a low slope, and the slope steadily increases. So it starts out with a low value and steadily increases. So that there makes some sense there.
And what would the displacement versus time look like for the velocity graph?
All right, let me throw one other thing in here first though. Technically, there are a lot of velocity time graphs that would match this acceleration. That also matches the same acceleration, assuming that those two matched each other. Really, if you're going in this direction, what you're finding is change in velocity. Or I would have to tell you the initial velocity so that you know where to start. So, but if this is, so let's say that it's set up so that I've established that's my initial velocity. I'm not worried about this at all. That's my initial velocity. What would my position time graph look like? Or actually my displacement time. My displacement time. I know that this is the slope of it, so it starts out at some some positive number. That's a dash there, that was not a negative sign. It starts out at some positive number and becomes more and more positive. So my position time graph starts out at some positive slope and just becomes more and more positive. So something crudely like that. Now, in order to do position time, I'd have to tell you some other piece of information, such as the initial position, to know where do you start this plot. In essence, if you think about it in terms of I have some function of time, I have something times t to the, we'll just say nth power. As I do slopes, that number gets smaller by 1. As I go the other direction, in essence, area under the curve, this number gets bigger. So, in essence, if my position graph is proportional to time squared, my velocity graph is proportional to time, and acceleration graph is a constant. If this were proportional, if acceleration is proportional to time, this would be t squared, this would be t cubed, etc. So if this is t to the 5th, my acceleration curve will be a 4th power, and this will be a 6th power. Is that sufficient?
And then if you wanted to find the exact number for velocity to displacement, could you take the area under the curve? Would you do that with a tangent line?
For area under the curve, it's not really a tangent line. You'd have to do some sort of crude approximation. So if this were my velocity time graph and I was trying to produce that, I would come up with some sort of rectangle system here. I know that in this amount of time, that's roughly gonna be my displacement right there, whatever the area of that is. And then here, I pick some middle spot, find the area of that one. In essence, you're doing integral calculus the hard way. If you know calculus and I give you the equation, feel free to use calculus if you want. Does that answer your question?
Yeah.
Okay. Good one.
Can you explain how it's possible to have constant non-zero speed and non-zero acceleration?
Constant non-zero speed.
Yep. Non-zero acceleration.
All right. Acceleration, vector acceleration. Is the change in velocity over the change in time. Go back to the car analogy. Or first, tell me what's velocity.
Change in displacement over change in time.
It'd be changing position, but okay. Give me the less mathematical version of it.
How fast you're going in a certain direction.
Okay, so if any of that changes, there's a change in velocity and therefore there's acceleration. So if I'm saying speed is constant, the only thing left that I can change from velocity is the direction. And so therefore, if I travel in a circle at a constant speed, my direction is constantly changing, but my speed stays the same. And since my direction changes, there's a change in velocity, therefore there is acceleration.
So a non-constant velocity could be 20 meters per second the entire time as long as it's turning?
Yes.
Is that the same reason that it's possible with the curve example in the master set? Yes, is it possible for something to have a constant speed in a curve if it doesn't have a constant acceleration? Or if it has zero acceleration?
Yeah, I don't remember the exact wording of it, but yeah, I mean any of the places where you've got speed is constant and velocity is not, or vector acceleration is not zero, look at changing the directions.
So non-zero acceleration just means that there is acceleration? Like, because my confusion with that problem was that I thought non-zero acceleration meant that it was accelerating, like as in speed was increasing. Like as in like acceleration was like 1, which means velocity was increasing in terms of the magnitude of the velocity.
Yeah, that misinterpretation.
Okay,
That if there's acceleration, if I just say that I have an object that's moving and it has some acceleration with a vector, you have no idea without more information whether it's speeding up, slowing down, or changing direction. Your steering wheel is an accelerator because it will change the velocity.
I think that the confusing part was that it said 0, which is a numerical value which you can't really assign to turning, which makes me think that whenever I read the question, it made me think that we had to be speeding up or slowing down because it had to be non-zero.
Again, non-zero acceleration. If I say non-zero acceleration and I don't put the vector symbol over it, then that has to be speeding up or slowing down. But the vector, that is one of the tricks or the nuances. It's one of the aspects of when you're dealing with the vectors, you have to remember direction matters.
So even if acceleration is 0 and it's turning, it's a non-zero acceleration?
In terms of-
If the object is turning, it is non-zero acceleration. Vector acceleration. Now, do you want to re-ask that? I'm not quite sure I really answered your last question.
No, I think you did. I was
Okay.
asking if, as long as vector acceleration is turning, it can be 0 and still be non-zero acceleration.
It can't be 0 because if you're turning,
It'll slow down.
not, and some of this we'll get into in, well, probably tomorrow, but no, Thursday. At some point in the near future. If I'm traveling around a curve like that, at a constant speed, so if that's my initial velocity and that's my final velocity, I know my acceleration, the vector form, is the change in velocity over change in time. My change in velocity is just the difference between those two. Well, I want to find the difference. I got VI going this way, and I got VF going that way. My change in velocity is a vector. That's my change in velocity right there. So it is, so if I'm changing direction, my change in velocity is not zero, therefore my acceleration is not zero. Your look says that you're not particularly satisfied with that answer. Did I misunderstand your question again?
I think my gripe with the, like the way the problem is worded, I think it's just like, it's a personal misunderstanding of it, but it's that like, in this scenario, if we're talking about the magnitude velocity or like speed, the speed is the same, so there's no change, so the acceleration will be 0 meters per second, wouldn't it?
But there's two accelerations.
But exactly, but it's turning, right? But so the turning means it's non-zero.
Means the vector acceleration is non-zero, correct.
The thing for that maybe you misunderstand the problem was that I thought non-zero meant that it was not 0 meters per second.
Yeah, yeah. Sorry, an unsatisfying answer, but that's just not the case.
I just misunderstood the wording of the problem, yeah.
Part of it is trying to break you of your preconceived notions of acceleration.
Would scalar acceleration be 0?
If your speed doesn't change, your scalar acceleration is 0. It would be really nice if they had two different words, but they chose not to. And I'm not in a position of power to change that.
So I have a question about this specific problem.
Yep.
Objects traveling in a curve at a constant speed have constant non-zero acceleration. Is the problem with that constant non-zero acceleration because the acceleration is always changing due to the fact that it's changing direction?
Yeah, so if I'm cruising along with some velocity, so let's say that's my velocity vector right there. If my change in velocity and my acceleration, vector acceleration will be in the same direction. So if my change in velocity or my acceleration is perpendicular to it, that's going to cause a change in direction. If instead I have a velocity here and my acceleration is not perpendicular, so that means that part of my acceleration is perpendicular, part of my acceleration is in the same direction. So what's going to happen here is that the vertical component, or the way I've drawn it, my perpendicular component is going to cause a change in direction. The component that's in the same direction as velocity will cause a change in speed. So if I have a constant acceleration, constant vector acceleration, we've dealt with problems like that. Projectile motion is a constant acceleration problem. That there will be a point in the curve in which it does change direction but doesn't change speed. However, that's only for a brief moment, and then the speed is going to change. It's either going to slow down or speed up. It's only at the peak where you've got that acceleration is perpendicular to the velocity. So in that particular one, that was it constant velocity or constant speed and constant acceleration?
Yeah, constant non-zero acceleration.
Yeah, that at some point, even if you got a brief moment where it's perpendicular, right after that brief moment, the speed is going to start to change. Which does bring up another thing that I saw. And it was stated, this is in the linear motion lab. Velocity and acceleration default, unless I state otherwise, are instantaneous. Displacement, unless I do otherwise, is overall. But when instantaneous displacement, I have to say instantaneous, like I do in the, there was one table where there was that last column, which was instantaneous. These are the default terms that, unless I say otherwise, this is what I'm assuming. If displacement is constant, without any other qualifiers, if displacement is constant, whether it's 0 or not, that's irrelevant. If displacement is constant, that means my overall displacement, overall where I am relative to where I started is constant. What does that mean in terms of my motion?
There is no motion.
And a number of people miss that. So, if displacement is constant, you're not moving. Whether it's 0 or not, again, is irrelevant. If it's 0, that means you're at your starting point and not moving. If it's not 0, that means you're not at your starting point, but you're not moving. Either way.
So displacement is constant?
If displacement is constant, that means you're not moving. Other questions?
Is there like a review we can do, like, recording this? Like,
Last Thursday? That's been recorded.
you said what?
Last Thursday, I went over and I went over a test.
I remember that, like, I just,
Yeah, I guess last Thursday was a little bit chaotic, depending on where you were at the time. Although from my understanding, it turned out to be something stupid, but that doesn't change how you were particularly feeling at the time. So there is counseling available if you need it. But not for Kristen, because she was not here when I started that. I assume you were flipping us off just then.
No, I would never.
I'd be shocked if you never.
Can if you want me to, though.
So anyway, if you're not quite sure where the recording is, if you go into coursework at the very top, it says sample test. I probably should have labeled it sample test 1A, but it's sample test. And below that, there should be a link to the YouTube video where the 2 hours or hour and 50 minutes or hour and a half somewhere. Just an extravaganza, something that you probably just want to show all your friends and family.
I showed my mom one of our lectures. She said it made her head hurt.
Because she wasn't able to watch more, I'm sure. Hair of the dog.
My dogs go sound asleep when I play your videos.
Better than the Charles Mingus album. Since I'm about to shift gears, let's make